Hello everyone, this is Prabha Hamiti from 3rd ECA. I'm gonna present a journal paper from International Research Journal of Engineering and Technology on modern traffic control system. This was published in January 2019 by the authors Shiva Chandal, Shubranash Yadav and Sandeep Yadav. And next we're gonna see abstract. In this paper, the authors introduced fuzzy logic in the solution of traffic control. Nowadays, we are facing a lot of traffic problem due to an increased number of vehicles. People are unable to reach their destination on time due to huge traffic. This fuzzy logic signal control is an important method to improve the efficiency of road network and alleviate traffic congestion. So this paper researched traffic signal fuzzy control method on a single intersection. Here we're gonna set two factors, that is number and rate of vehicles approaching towards the traffic signal poles. And here the simulation is done by using a fuzzy logic toolbox in MATLAB. And the next slide is control system concept related to this journal paper. Here the modern traffic control system related to the control system concept is the basic control system structure and components. See here, the basic components of the control systems consist of input, output, and the process being controlled, sensing element, and controller and actuating devices. So according to this, in this journal paper, we have used two sensors. So the sensing element is related to this top concept of control system, and this is a traffic signal, right? So the people have to wait till the timer runs and the signal turns green. So according to this time domain system, the control system concept is related to this journal paper. And the next slide is author executed concept, the simulation. So here, neural network and fuzzy systems are dynamic parallel processing systems that estimate input-output functions. And they estimate a function without any mathematical model and learn from experience with sample data. Fuzzy sets are considered to be advantageous in the logical field and in handling higher order processing easily with a higher flexibility. See, fuzzy logic and neural systems have very contrasting application requirements. For example, fuzzy systems are appropriate if sufficient process data are available, while neural systems are useful if process data is measurable. And therefore, the integration of neural and fuzzy systems leads to a symbiotic relationship in which fuzzy systems provide a powerful framework for expert knowledge representation. So the significance of the integration becomes even more apparent by considering their disparities. See here we have used two sensors, right? So we can see that in next slide, the hardwares. So this technique is implemented by using two sensors to give the input to the fuzzy inference system. So they had used acoustic sensor and Doppler and radar microwave sensor. So the acoustic detector detects the vehicles on the basis of sound generated by the vehicles as it passes the sensor. This sensor is mounted on the pole which is pointing down towards the traffic. It can collect counts for one or more lanes. Someone can communicate their counts wirelessly. So the next sensor they used is Doppler radar microwave sensor. So it is used for detecting distant objects and the speed of movement and their position. This device directs high frequency with the detection and time delay of the return signal to direct vehicles, thereby calculate the distance to the detected vehicle. So here, the acoustic detector and Doppler radar sensor is installed on a pole 150 meters away from the traffic signal, which counts the number of vehicles on the basis of sound generated. And this serves as an input for fuzzy inference system. So the next slide is author's conclusion. So here, this paper proposes the concept of intelligent management of traffic control without involving much change in existing design. As time is very precious, so this system will help in saving a lot of time, which is wasted unnecessarily due to traffic signal proper working. And this will not only save time but also the fuel burnt unnecessarily and the saving environment and money of an individual. This will make the road transportation more convenient and easy. Next is a future scope, right? So here in the preceding sessions, many topics were discussed, right? But it is important to continue to look for further innovations outside the traffic world that may be of interest for traffic management. For example, we try to make full use of new information and communication technology developments. So far, there has been a little rigorous focus on the influence of social media on the use of traffic information. In addition, it is prudent to keep an eye open for developments in other sectors. A study of analogies can determine whether developments and innovations elsewhere may also be useful for application in the traffic management. So next, I had learned some concepts from the Modern Traffic Control System journal paper. I had learned the working of acoustic sensor that um, I had learned that aquatic detector detects the vehicles on the basis of sound generated by the vehicles when it passes the sensor. So it will generate the vehicle uh, by the sound, right? And the working of Doppler radar sensor, it will detect by the distant objects and the speed of movement and their position. The next, they had simulated this concept by fuzzy logic toolbox in MATLAB. The fuzzy logic toolbox in MATLAB, which has a graphical user interface to efficiently design and implement fuzzy control system. Although it is possible to use the fuzzy logic toolbox by working strictly from the command line, in general, it's much easier to build a system graphically. So that's all about my presentation, and thank you. I hope it helped you. And my presentation is good.